All right. So the Pro, again, is the eBick line. Obviously, it has the same structure as the Ultra. We have this model for, again, Pro indicates that it has higher outcomes, but not that is not treated in a professional way, of course. This system, always we're talking stationary. I mentioned that because we have used the Ultra in some applications that are not stationary. Amazing enough, we were contacted by a company manufacturing tracks, but what they wanted to do is not fit the track, but fit all the equipment that was in the track. It was some sort of rubbish track that had a lot of pieces of equipment on top of the track, and they wanted to fit that, and the Ultra proved very useful for that. In this case, no, I mean, it's 100% stationary applications. We recommend it for systems. I mean, we put here 35 kilowatt hours, but again, whatever can be done with the Ultra, you don't need to go to the Pro. So it could be perfectly, say, starting at 70 kilowatt hours, and then with the ability to escalate up to 5 megs or more, okay? Another particularity of this system is that it works in different voltages. The basis is always the module of 48 volts, but it can be connected in series, so we keep increasing the voltages. And we have deployed systems up to 800 volts, okay? In terms of power, this is something I didn't mention. The Ultra is called Ultra 100 because the continuous discharge current is 100 amps, okay? It's a 0.6 C. In this case, the Pro, being of a higher product, is 1 C, so the continuous current, it's 180 amps per module. And in this case, when we're working with higher capacities or higher voltages, we always work with communications. We don't have the option to work without, okay? That's a big difference. And talking about that, at this moment, we are compatible, we are integrated with these inverters. There are some others, but are not available in Australia. The first three, everybody knows, SMA, Victron, Selectronic. Both Studer and Ingecon are available in Australia, but they are very residual. In the case of Studer, because they are not promoting it, I don't really understand why, but still, they exist. Ingecon, we are really good friends with Ingecon because, in fact, Ingecon is from Ingeteam and we are neighbors in Spain, so we know each other very well. Here in Australia, they go for the higher projects. When?
Almost, they got bleeding nose.
What's that?
They had some trouble here in Australia.
With the small ones?
No, with central inverters.
Well, I don't know if they had trouble or no, but they are, believe me, they are getting into a lot of projects. A lot on grid level, and it's a really good product. It is, so I understand. They had problems, well, who doesn't? And Riello is an Italian company. We work a lot with them in higher voltages. They have really good inverters in, I would say, in the steps of 200, so in 200, 4, 6, and 800 volts. But that's not their main business. Their main business is the UPS systems, and they are here in Australia, formally established and everything, but just with the UPS. We try to convince them to come with us, and still we are waiting just to see if they want to. But it's a pity because they have all the structure and everything, and it's a very well-established company. So in any case, at this moment, in order to have the full comms, this is the standard integration that we have, okay?
Just one question, because before you said, when you have unmanaged unit, go set up as LED as a battery, set up values. When we do a managed You're not really using actually lithium settings. Yeah, we did identify.
Yeah. Well, in the managed setting, yeah, you're absolutely right, but it's not so manual. I mean, with most of the inverters, having passed the integration, we are an option in the menu already. So it presets most of the stuff. Then you might change some values according to the application, but it's part. I mean, that's part of the integration. So you don't need to bother about the small details because they are already on the setup.
Another question: what is the weight of a cube?
Excuse me?
What is the weight of one brick?
What is the weight? 100 kilos.
100 kilos.
Yep.
Okay. How high are these bricks?
Okay, this one in particular, it can go up to 4.
Up to 4.
Yeah. And in fact, I'm gonna show you
Some recommendation for lifting?
jack pallet with jack pallets. Yeah.
Get Arnie back.
In fact, if you see how it is set, this is already set already to use with a jack. I mean, of course, if you have a forklift, it's fantastic, but if not, I mean, exactly the same. I mean, this is why it has this arch here. It's designed for that. Okay. So again, we're talking a modular system. So we keep adding different modules, like a Lego system, just connecting one to each other. Same characteristic, scalable. You start with a small factory. The moment the factory grows, you add more modules. The moment you have the whole building, you add more modules, and this is the basis. And here is probably more important when we talk about how compact this is, okay? All the promotion, all the marketing, all this always shows this configuration. You see a nice wall and all the modules put against the wall, they look very nice, perfect for the picture. But when we are talking efficiency of space, because in some cases space is an issue, you can do different configurations, okay? For example, this column configuration here, you have 12 modules. This accounts for around 100 kilowatt hours, slightly more, but 100 kilowatt hours. In terms of surface, is less than 1 square meter. Here, the only thing you have to take into consideration is the cables. So, I mean, for us, this product is a project. I mean, the Ultra is more an off-the-shelf product that someone can take and do their own, especially unmanaged, or managed, as you saw, that it's quite simple. This one is more of a project. I mean, we like to know where it is going to be set, what sort of application, make sure about the configurations. We help with that. And also, if the layout is going to be different from the traditional one, we also recommend about the cables. We can produce them ourselves to measure, etc., etc. But this is how compact it can be. What are the components of this system? Well, the module, 48 volts, okay, 180 ampere hours, can provide a continuous current of 180 amps. It's composed by 15 prismatic cells, LFP. Cyclability, in this case, I misunderstood you before when you're talking about the cyclones. Okay. As a standard, we have to put a number. I mean, you need specifications, we put. We are probably one of the only ones that we don't say 5,000 cycles. We say over 5,000 cycles. Why? Well, because we know that the cycles are affected by many, many variables. It's not just the DOD, people related to the DOD, but there are other variables as important. It can be the C rate that you are using constantly, the battery. It could be the temperature range where we are using the battery. So there's really an amount of variables there affecting the number of cycles and the end of life of the battery. Because we consider this product as a project product, if the customer wishes so, we make a study on how the battery is going to be used, and we can adapt the warranty to that. Okay, some clients are very specific with the use that they are going to make out of the battery, and they want to extend the battery in some sort, maybe in time, maybe in cycles, it depends. Well, we don't say no. We just adapt and customize once we know how the battery is going to be used. We had an example in Victoria. It was one of the electricity companies, and they knew exactly how they were going to use the battery. I mean, it was 2 cycles a day, 1 in the morning, 1 in the evening, to that extent, and they were ready to oversize the battery in order to have more longevity. Okay, and they said, listen, you are saying 5,000 cycles, but we need 7,000, which was the equivalent of, I think it was, if I remember well, 2 cycles a day during 10 years or something like that. When we calculated, the DOD that they were going to use, it was around 63%. Well, with that DOD, the battery suffers much less. It suffers much less degradation. And we accepted. We said, okay, we'll do it. I mean, we will guarantee the battery for 10,000 cycles instead of 6,000 or 5,000. 10 years, that it was 7,000 cycles, because you are using the battery the right way. The right way. Probably the most strenuous thing in that project was 2 cycles a day. That's quite big for the battery. But the fact that it was used such a low DOD, it would help the case. Okay. The battery offers Anderson connectors as well. It can offer, in terms of cones, it could be either CAN bus or Modbus. And this is the dimensions. So the largest key, around 100 kilos. The second component of the system is what we call the MCP, which is the module of control and protection. I don't think we have any here. Okay, it's like a box like this. Okay. These systems are thought to be in strings. Okay, as the basic of the system. The string can be as low as 1 module, or it can be as large as 24 modules. It doesn't matter. It's still a string. Okay, and those strings can be then parallelized. Okay, each string always is going to have one of these MCPs. It doesn't matter if it's 1 module or it's going to be 24. It needs one of these modules of control and protection. What it's doing is like an external BMS. So it's a BMS for the string, not only for the battery, but for the string, in the case that we have many batteries. So it controls all the variables. It receives all the communications from every single module, and is the one offering those data to the inverter in order to take the right decisions. The MCB comes with a small screen. It's a touch screen where you can check absolutely any detail of the string or the modules. Everything is in there, in different formats, in numbers, in graphics, and also, of course, that can be extracted as well. And with an internet connection, it can be accessible in a remote mode. So if we're talking in a 48-volt system, well, it's very similar to the other one. We just keep connecting the modules in parallel. The limitation in this case is 24 per string, and one MCP can control up to 24 of these modules. When you were talking before about the limitation, in fact, the limitation of the current comes from the MCP itself. Okay, we have a standard MCP, which is the MCP 300, so it can take up to 300 amps. There's a peak of 360, but of course, I mean, after 3 modules, you get stuck. You get stuck with this 300. Because there are systems that might require more power than that. We have an MCP 500 and one MCP 1000, okay? Not only that, if you have this system and you require more power, you can split it into smaller strings, each one of its own MCP, and then the moment you are parallelizing those MCPs, you are increasing the power as well. Okay? So there are several ways. The same system can be configured in many different ways to obtain different power, different redundancy. There's a lot of things, and that's why we consider it's a project-based product and not just something off the shelf. There are many things to take into consideration. Okay? This is an example for a small module, for a small system. Again, in a system like that, normally we would recommend the Ultra, but just to set an example and to understand how the things are set up. Well, in this case, it's a 52 kilowatt hours. We need 6 modules. They are connected. In parallel. What I was mentioning before, because there are 2 columns, you need 1 extra length cable. In this case, it's coming from here. Okay, so it's having a U, and the same with the communications. It's going here and goes underneath. Okay, but that's all what you need. The platform is an element that is required because it's what giving the enough strength to put the 4 heights, because at the end, if you think about it, it's 400 kilos. So this is part of the structural base of the systems. Okay.
Can we just go 1 slide back?
Can we? Yes.
Okay. So you have a wonderful system actually configure a nice big battery. Yeah. And you're limiting this battery to what is this? 400 amps. Yeah.
Mm-hmm.
Nominal current. When I touch such standard Sunny Island 3-phase cluster, it's a Sunny Island 8, rated for 18 kilowatt output or 24 kilowatt peak. So I actually would need to have a supply of 500 amp.
Mm-hmm. So you can change the MCP and put an MCP 500.
You actually just set it up onto your BMS, or it's just a matter of the BMS then?
No, the BMS is different.
Yeah.
It's a different model. One is the 300, another 500, another. This is what you mean? Sorry.
Yeah, no, that's what I mean, yeah.
So there is a bigger MCP?
Yeah. That's what I'm saying. I mean, there are different sizes in terms of current. There's the 300, the 500, or the 1000. It's not a setting. It's a different piece of equipment.
Okay.
So the battery can provide that current.
Yep.
It's just the MCP
Which is limiting for security.
When you look into it, here's 1, 2, 3, these models next to each other. And yes, okay, one model with 180 and parallel, 2 models next to it is 360. My other question was, I have 3 models on stacked of each other. So all 3 models, each model has 180 amps output capacity. So what is the maximum current I can actually draw out of one string?
Again, this is limited by the MCP.
Yeah.
So if you have the 300, the maximum you can have from 3, it will be 360, 400. If you use the other MCP, you can go higher. But the MCP is the one regulating what the batteries are doing. So it doesn't allow the batteries to provide more current. Even if the batteries can, they are limited.
Okay. Yeah, okay, later.
Yeah? Okay.
Quick question that, like so the power connection is going through the MPC, say MCP.
Yeah.
Yeah. So and it has its own circuit breaker, I guess.
Sorry? Yeah.
May I know the rating? Do you have any idea of the rating of a circuit breaker?
I'll have to check it.
Sorry.
I don't know by heart.
Sorry, so the output of the battery, so we just plug into the MCP,
Yep.
the inverter.
Yeah. Okay. There is. I'll show it slightly later, but again, because we're talking here parallel connections, okay, there's a recommendation to use a bus bar, okay? And then they'll go to the bus bar, and from the bus bar, they go to the MCP. And I'll show you slightly later, we even have a proprietary bus bar, which is not mandatory, okay, but it's something that we offer because it's an inexpensive option that matches with the rest of the system and quite easy to connect. And that's the one that goes into the MCP, okay? And I'll comment slightly later as well, when you connect different strings, in this case, for example, if you replicate this system and you put another one in here, then we enter into a slave master system where you have another MCP on top controlling the slave MCPs, and that one manages only the communications, not the power.
What's the biggest MCP you have?
The biggest?
Yeah.
1,000.
1,000.
Yep.
Okay.
And earlier you mentioned that, okay, for now you only need 3. And then later on, if you want to expand, then you can add more. This one you cannot connect the existing with the new one because they are different lifespan already.
It's a good point. But if you find a way to equilibrate them, it's possible. I mean, of course, if the system is 10 years old, you might have a lot of trouble. But if the system is from last year, you can keep balancing them. Okay. I mean, again, it's not so much the life, but how much the battery has been used. Okay, and how degraded the level of degradation is in there. Okay.
And also for the communication, you said on the MCP we can extract the data.
Yep.
Does that data extracted from the Cegasa portal or from the inverter itself?
Or from there?
From the Cegasa portal or from the inverter?
No, in fact, we provide. It's not a portal. Okay. It's a direct connection. Okay, we provide the software, so you do a point-to-point, let's say, but without a portal. We are creating the portal. The portal is on the way, but so far it's a direct connection.
How many configuration of these can I put parallel?
How many?
Configuration of that can I put parallel? So you have one configuration, maximum MCP is 1000 amps. How many times I can put parallel 1000 amps to actually exceed my capacity?
Okay.
Because 1000 amp by 48 volt or 48 kilowatt is nothing.
This is high voltage.
Okay. One MCP can hold up to 24 modules.
I'm not talking
One second. Let me finish. Okay? Okay? But that doesn't mean that you need to take it to the 24. If you want to put 24 modules, you can put them in group of 3s if you want. This way you will have 8 MCPs. And then you will be multiplying the power of the MCP by 8 because they are connected in parallel. Okay? Of course, it looks too extreme. But if you need that power, I mean, I don't know what sort of application might require that power, but if you need it, even the most absurd way would be 1 MCP per module. And you would multiply the 1,000 for 24,000 amps if you want. Doesn't make sense, obviously, but I'm taking it to the absurd just so you can see. The moment you are working with the strings, okay, you can parallelize the strings, but the strings can be as big or small as you decide. And it's a combination on the power that you require and the redundancy you want to provide to the system. And again, it's a project basis. We work with the customer saying, okay, we recommend this configuration because this is your requirement. Okay? Yeah, we went through that. Fast assembly, the MCP per string. Examples at 48 volts. Okay? In this case, with the Sunny Island, 164 kilowatt hours. This is an absolute off-grid system. It's a chicken farm, panels, the genset. But again, in this case, what I was commenting about the bus bar, this box here is not a battery, it's a bus bar module. Okay? Yeah, it's again, we offer it just to make the composition of the system the same. Very simple because it has the right amount of plugs depending on the strings that you are handling. And this is the one connecting to the MCP, and then the MCP connecting to another one. In this case, I think there are 2 different strings, I believe. Okay.
The busbar box comes with a protector as well, so a fuse protection or a breaker or anything.
No, that goes into the MCP.
That sits in the MCP sits on top of that, yeah. Okay.
Yep. The busbar, I'll show you It's just a box with the busbar inside, and then the number of outputs that you need. It might be from 1 to 4. We are doing, in fact, 5 right now. We can take up to 5. But again, this is something that the installer himself can do his own busbar. It doesn't have to be this one. We just offer this for the simplicity of the system. Okay. Okay, some other examples. This is one of our partners in Germany, Maitzel. I don't know if you know them, Maitzel. They do a lot of Victron stuff and smaller systems. Now they start to work with the Ultra as well, but they've always been in the beginning with the Pro. I don't know. I'm not really familiar with the applications that they have, but they use it a lot. This is what I was mentioning before, Riello. We work with them in different voltages. In this case, 48 is the less common, in fact, okay, that we use with them. So, high voltage systems. Again, the product has the ability to work in multiples of 48 volts. We connect the modules in series, and this way we increase the voltage, okay? So if you want to reach 144 volts, you just connect 3. If you want to connect at 400, was around 432, you connect 9. Again, the limit, we have put it on 800, but just because this is the project that we found. We haven't gone any higher. We are quoting right now something on the edge of 1,000 and something, but I haven't seen the specs yet, so I'm not gonna get into that. No. Well, this provides the advantages of working in lower currents, and I'm gonna explain here. This is the most common setting that we find here in Australia. We have done a few projects with this setting. So basically, we connect 3 modules. In this case, this column, as we call it, this column is 26 kilowatt hours at 144 volts. And then what we do is just parallelize the different columns. In this case, one MCP can take up to 4 columns. So we can work in blocks of 100 kilowatt hours, okay? Does this mean that we need to work in blocks of 100? No. I mean, again, it can take up to 4 columns, but it could take only 3 or only 2 or only 1, depending on the power that you require, okay? This I already mentioned. This is a real case, okay? This is in Fraser Island. In here, the main concern of the project was the redundancy, not so much the power, but the redundancy. This system is powering the headquarters of the rangers in Fraser Island. They have a lot of sensitive equipment connected to it. So what they want to ensure is that whatever happens in the system, there will be always some power on. So they chose, under the capacity that they wanted, around the 150 kilowatt hours, they chose the configuration with maximum redundancy, meaning that if any of the strings fail, the other 5 will keep going, okay? And in fact, is what we use if there is any sort of maintenance, any sort, for example, when we update the system, when we update the software of the system, we do it one by one. We stop one string, update it there, then the next, then the next. There is always 5 strings on at the same time, okay? In this case, in systems of this size, we also provide the cabinet, we call the cabinet, where we have the general busbar in there, connecting all the different strings. There are some sensors, some switches, and the MCP master. So one of these pieces is inside here as well, is the one controlling all the communications with the inverters. In this case, this electronic. This electronic, I mean, as you know, they have a range on the 120 volts, okay? I'm gonna say that they are offering us as the best option in the 120 volts with communications. They don't have many options there. There are some other options in the market without communications, but with communications, Now, if you ask them, probably they will address you to us, because we've been doing this. We've been doing this project with them, and it's working very well. This is the project in Fraser Island. Okay. All of this is just one container. In fact, this is the same container. There's a separation wall around it, okay, if you can imagine. So this space is habilitated for the different inverters, and the rest is habilitated for the batteries, okay? Over there are 460 kilowatt hours, okay? But it's not taken to the limit at all. I mean, there is a fourth level that hasn't been used, and there is the space that corresponds to the systems for under 200 kilowatt hours. But above that, you don't need to give that much space, meaning that in that container, you could have fit perfectly 700, 750. I'm absolutely positive. So it's really, really a good option, okay? So I would say that this is almost everything. Just before I finish, this is the next generation. This is already in production, okay? The 180 is going to become the 280, which means that on the same box, same weight, same dimensions. This is slightly heavier, but I'm talking, I believe it's 105 kilos. So, I mean, the difference is very, very small. There will be 60% more capacity inside, okay? This has been possible with the change of the cells, a new generation of cells, much more dense. And, well, each module will be from now on 13.4 kilowatt hours. We are going to change also some of the connections, especially the serial ones. That's going to be hardening. And the communications are going to be simplified as well with the standard RD45, okay? That will be available in Australia by the end of this year. And if you think about what we were talking before, space and density, what I told you before, that this composition was 100 kilowatt hours, with the new module is going to be 160 kilowatt hours in 1 square meter. Or this configuration that we said is very common, the 144. In this case, each column is going to be 40 kilowatt hours. So, I mean, the blocks right now can be as high as 160 kilowatt hours, okay? In most cases, it means that for the same system, there will be less modules, less components, and also it will be more cost effective. And that's all. Thank you very much. I hope it's not been very boring. And again, it's a very general view of all our offering. I can take your questions as much as I know. If I don't know, I'll find the answer for you. Inside the bags, I also put my business cards, so if you need to connect with me, please do so. And well, there's still donuts. So
Thank you very much.